and welcome to another Seeds for the Future webinar. I'm today's moderator, Maya. I'm thrilled to be back. We had over 100,000 viewers during our previous Seeds webinar, all about generative AI. We're so excited to be here today, diving into another fascinating topic. Speaking of the topics, today's webinar is all about space travel, and how digitalization impacts on that and takes us there. Space, the ultimate frontier, the vast expanse that we only know as little as about 5%. It was once an unknowable, unreachable place. But over the past years, we have witnessed the incredible technological and engineering achievements that have prepared the frontier of human exploration. We are here today because we believe that one day the space travel would be eventually open to everyone. Space holds tremendous potential for aspiring individuals like you. With space travel and digitalization advancing rapidly, it opens up opportunities to anyone who's passionate about the cosmos. Today, we've gathered some of the brightest minds in the field to share us their thoughts on the latest developments in space tech, challenges, the opportunities, the career developments, etc. First of all, let me introduce our special guest, Dr. Suzanna Randall, an astrophysicist working at the European Southern Observatory and currently an astronaut trainee in a space flight program whose goal is to get Susan to become the first German woman in space. Hi, Suzanne. You can say something to our audience.
Hi, I'm delighted to be here, and I'm very happy that I'm going to be sharing my journey into space with you in a bit.
Thank you and welcome. We also have my colleague, Andrew Williamson, who's currently Vice President and Economic Advisor of the Global Government Affairs at Huawei. He's obsessed with the topic of digitalization and what it will mean for technological advancements across the industry, including space. Hi, Andrew.
Hello, everybody. It's a great honor to be here tonight for this discussion. I'm very much looking forward to it. I'm a huge space fan, space travel and sci-fi. First film I ever saw was Star Wars, so that sets the tone. And but also really interested in digital technologies, and we'll be talking about that and space travel this evening.
Thank you, Andrew. These two wonderful guests are joined by two of our Global Seeds for the Future ambassadors, Daniel Mako and Ernesto Brightuno, who will be leading the session today. So it's the turn for them to introduce to our audience. Daniel, your turn.
Hi everyone, I'm Janelle McCoy from Jamaica, and it's a pleasure to be here.
Thank you. And Ernesto? Oh, Ernesto, you are muted. Maybe you need to turn on your volume.
Hi, I'm sorry. Hi, my name is Ernesto Briseño. I'm from El Salvador, and I'm really excited to be here with all of you.
Thank you both. I'd like to invite all our participants to ask any question you have in mind to any of our speakers. We will come back to you and address them during the audience Q&A session. Shall we fasten our seatbelts and blast off? Let's go. Dr. Randall, I'm especially fascinated by your journey to becoming the first German woman in space. What does it mean to you to be the first German woman to travel to space? How did you decide to train to become an astronaut? I'm sure those are the questions our audience would very much love to hear from you.
Oh, yes, I'll try and answer them. I'm going to start with the presentation and any other questions you have, because in the few minutes I have, I can't cover everything. So you're very welcome to ask me afterwards. So yes, I'm going to talk about becoming Germany's first female astronaut, because Germany has never had a woman in space, unlike most other countries, including China. So to start my presentation, I have always been fascinated by space. So this is something that I've wanted to dedicate my life to ever since I was a small child, and that's why I became an astrophysicist. So right now I observe with the biggest telescopes in the world, and I look up into space, and I love trying to understand what we see up there. But I always had this childhood dream of also going into space myself, of becoming an astronaut. So in 2018, I happened to be on my lunch break and I saw an advert. And this was the advert, what you can see here, Die erste deutsche Astronautin, which is German and means the first female German astronaut. And I saw that they were looking for astronaut candidates to apply. So for German women to apply to become an astronaut. And in fact, this was, for me, very exciting because first of all, I wanted to become an astronaut. And second, I didn't really realize that there had never been a German woman in space. So actually, the objectives or the mission of this program were to bring the first German woman into space, but to also show that there were enough qualified women also in Germany to become astronauts. And this was one of the big successes already of our initiative. You can see here on this slide, these are a large percentage of the women that applied. So over 400 German women applied to become an astronaut, and I met most of them, and I can really say these were very talented women in all the different STEM subjects. So in Germany and in much of the world, we have the problem that women are underrepresented in the STEM subjects, and we really wanted to show that no, women can also be good at technology, at engineering, at maths and physics. And I think we achieved that just by having so many wonderful women applying for this astronaut program. So after a one-year selection process, in the end, 2 women were selected. There was my colleague Inzatila Eich, who is also a scientist, a meteorologist, and myself as an astrophysicist. And we then started training to be an astronaut. And I am often asked, what does astronaut training entail? So people think I'm running from one survival training to the next. But actually, this is more what it looks like. So we have a lot of theory lessons. We have to learn all about rockets. We have to learn about electrical systems in space, how you reuse water, and so on. We have to do simulator trainings. And we also do physical trainings. And the more fun trainings are really the ones where we can be practical and where we really learn new skills that we also need in space. So here, this was one of the trainings. It was to become a private pilot, so to get private pilot's license. And while you might say, okay, a small plane, like the one I'm standing in front of here, flies very differently to a spacecraft, the fundamental things that you learn are the same. So you learn basically to stay cool in very difficult circumstances, even when it's stressful, to just work off a checklist and to do everything correctly but quickly. So that is the key skill that we learned in flying. Then we also had underwater diving training, because underwater you can simulate microgravity, so zero gravity, 0G, being weightless. And also we learned how to walk around or float around in these very, very uncomfortable spacesuits, which really takes a lot of getting used to, I have to say. So it's very, very hard to move in these spacesuits. Then for me, probably the most exciting training we did was 0G flights, so parabolic flights. And what happens there, you can see on the diagram, you have a plane that is just flying normally, and it is pulled up very steeply, and then the nose is pushed down by the pilot. And the plane will be in free fall for about 20 seconds. And in those 20 seconds, you're completely weightless inside the plane. And there you can experience what it is like to be in space, to be in zero gravity. And really for me, that was my most fun training because it was just such an amazing feeling. And then finally, the last training that we did was a kind of survival training. We went into a cave for 5 days. So we went underneath the earth, and we found out what it was like to work in a small team of 6 people in sometimes very difficult circumstances. So it was dark and it was cold and we were wet and we were stressed and we had lots and lots of work to do, and we learned how to function under these circumstances. And again, that is one thing that we really, really need when we go into space. So I've talked a lot about the training. Why are we training? We're of course training to go into space. So let me tell you a little bit about our mission. Our mission is to go to the International Space Station, ISS. It's basically an international science laboratory in 400 kilometers altitude that is in orbit around the Earth. And that much is clear. We want to go there and we want to do scientific experiments. What's a bit more complicated is how to get there, because right now there are only 2 space carriers, so 2 spaceships that can bring people to the International Space Station, the Russian Soyuz and the Crew Dragon by SpaceX. So with the Russian Soyuz, things are a little bit complicated right now because of the political climate. So our preferred option is to fly commercially with SpaceX. And this, in a way, brings me to the rest of my talk, which is going to be about commercial space flights and about the opportunities we have there in the next years. So SpaceX has actually been extremely successful. Starting from 2020, they have run 7 successful missions with astronauts on board for NASA. So you can see all the astronauts that they've flown to the International Space Station and back here. But also, SpaceX have flown 2 completely commercial missions to the International Space Station. So it's really setting, I think, a milestone. It's a real milestone for commercial space travel. So there's a company called Axiom Space, which basically does all the organization around this commercial space travel. And together with SpaceX, they have sent 2 crews successfully to the space station. And for us from Germany, that is also our plan. So most of the private astronauts are either privately funded, so these are very rich people that just pay millions of dollars to go into space, or also the commercial space travel has been funded by the respective governments. In the case of, you can see here, the woman that is on the International Space Station, she's actually the first Saudi Arabian woman to go into space, and that was funded by the Saudi Arabian government. And we are hoping, we're in negotiations with the German government, that they will also be able to help us to bring the first German woman into space. So that is our plan for now and the near future. But looking a little bit further ahead into the medium future, I would say, what are the options for commercial space travel and where can we go? So the International Space Station, ISS, is over 20 years old and it's slowly becoming old. So things are starting to break and it's not clear how much longer we'll be able to go to the International Space Station. But then looking into the future, we have, as you in China are very much aware, I'm sure, the Tiangong Space Station, which has now been operational for just over half a year with astronauts permanently on board there. And I've heard that in the future, they might also accept international astronauts. So that would be really, really actually cool to have an international collaboration also with the Chinese space station. Then on the American side, Axiom, which is the company that I mentioned earlier that has been flying astronauts commercially to the International Space Station, actually wants to build their own commercial space station. And the picture you see here up in the top right is actually from their leaflets, and they say this is going to be a room with a view. So if you have the necessary money, which will be many millions of dollars, you can actually book a room on the Axiom space station and orbit Earth for your holiday. And then finally, the Americans with some international partners are also thinking of going back to the moon. So there is the plan to have the Lunar Gateway, which will be a replacement for the International Space Station, but not orbiting the Earth, but orbiting the moon. And the idea is that in the further future, this will serve as a base, not only to go to the moon, but also to go as far as the planet Mars, where, of course, no human has ever been. So I'll end with this and leave you wondering, could the next astronaut maybe be you?
Thanks for sharing, Dr. Randall. What an interesting story. And on the other hand, I would like to invite Andrew to share with us how the development of various digital technologies such as Computing power, mobile digital connectivity, and AI can complement the growth of the space travel industry. Let's hear it from Andrew.
Well, thank you very much, Maya and Suzanna. Let's check that the slides work. Yes, so I'll open here. Now, clearly, you know, Huawei Technologies is a company at the forefront of digital technologies, and I think, you know, there is. It's easy to say that that space travel and digital technologies have a long and intertwined history and relationship, and going forward as well. And I thought I would just, you know, share this, and for those that don't know, and share some of the history between how these different technologies have developed over time. So it's an often said statement about how the smartphone, essentially a mobile computer in our pocket, is vastly more powerful than the computer that was used to land people on the moon way back in the 1960s. But actually there is a really interesting story there about how they used to try and use valve technology at NASA to put the computers on the command module and the Eagle lander. But actually they moved to a brand new technology, which was microprocessors. So really, you know, this move to creating onboard computers in spacecraft really sparked the microprocessor revolution. And from that, you know, we had the whole computing age and the internet come from that. Likewise, it's a really interesting story about digital photography. Again, the technology of the time using film was unsuitable in space, and so as NASA and others were driven to create images from space exploration, they trialed new technologies which eventually evolved into digital photography. So another great story there, and I love this picture that we have of Saturn that was taken with the Cassini probe. With the arrow there, it was Earth just appearing above one of the rings. And again, that all came from this development of digital technologies. Then way back in 1982, the demands of the Space Shuttle program required and created arguably the world's first laptop. It was the Shuttle Portable Onboard Computing System, SPOC. All essentially laptop computers are derivative of that. But what I think is really interesting that's happened more in recent times is that many of the technologies, the products that we use today, such as laptops, smartphones, etc., are now so good that they are actually used in space programs. So netizens around the world keenly eyed the use of Huawei products, a Huawei P30 phone, and earbuds that we used on the Tiangong space station, alongside a Lenovo laptop and a Xiaomi electric screwdriver. So I think when we're thinking about, you know, where we're going forward with space travel, it's really important to kind of understand where we're going with these digital technologies. Now, as we go to kind of, you know, more consumer-led, mass market space travel, space tourism of the near future, then we're going to need to use new technologies such as laser communications, and we're going to need to be able to feed and look after ourselves in the hostile environment in space. So very quickly, I'll just touch upon research that we've done here at Huawei. It's called Intelligent World. It looks across 8 main areas, and it forecasts out based on macro trends to 2030. And I think it's really interesting here to see amazing stories. I mean, really quite breathtaking advancements that we think are really based on real data and real potential. So, for example, we think computing power is going to increase tenfold to 2030. But more interestingly, we think the computing power dedicated to AI will increase over 500 times. So it's very possible that we'll be using generative AI technologies, speaking to our spaceship computers in the near future. Likewise, we think the drive to forestall climate change will mean a big revolution in solar energy. We'll need these sort of technologies, solar energy, digital power, and nuclear power, if we are ever to have settlements off Earth in places like the Moon and Mars. And also, there's a big revolution that's going on in digital healthcare. The wearables, such as the one that I'm wearing here, they do an amazing amount of data recording and tracking. And these technologies, these digitalized capabilities will mean that we'll be able to do much more preventive healthcare in the future. We'll be able to track health data and come up with solutions for that. All these types of advancements will be really crucial for space travel and space tourism in the future. Then finally, on food, we can't easily grow food in space or on the Moon or Mars. So again, digitalization, factory like agricultural production, all these technologies we think will be very viable by the end of this decade and will be again crucial for space travel. So with that, I'll end there.
Thank you, Andrew. After these two wonderful sharing, I guess our ambassadors have more questions to ask and talk to our guests. So, Janelle, your turn to lead the first discussion.
Thank you so much, Maya. I must say that it was most fascinating in sharing with those presentations. They're really good. So thanks, Andrew and Suzanne. And so we'll just jump into it with our questions. And my first one goes to Suzanne, right? So tell me a little bit about the pros and cons of space tourism.
Oh, so it's actually a very, very interesting question, because in the media, space tourism is often portrayed as something very negative. At least in Germany or Europe, which is my social circle where I can speak from, it's very much, it's these rich people that are polluting our planet, that are going up just for the pleasure. And it's really not, for the good of humanity, that only some can afford this. So space tourism, I think, in the Western world has, with some, a rather negative connotation. But I see it's a bit more, nothing is ever black or white. Sure, you can argue, should people just be able to go to space just for the fun of it, without doing any research, without doing anything that helps us on planet Earth? But on the other hand, space tourism and commercial space flight has really helped the advance of technology. So you can see it with SpaceX, for example. They're commercial. The main mission was really to send space tourists up to explore Mars, to really do a commercial space flight. And they've managed to make, reusable boosters, for example. So they managed to make space flight also for humans much more affordable and also more sustainable. So I think there are two sides to the coin. But overall, I think space tourism, as long as it doesn't really go overboard, the problem is not everybody can fly into space. It's a good catalyst for technological innovation.
Okay, thank you. And my next question goes straight to Andrew, right? So we talk about computing power. What does that really mean, and how will it impact space travel?
Well, as I think I tried to show in my introduction, one has really led the other in terms of improvements. It was deemed as too risky, too dangerous for the astronauts to essentially pilot themselves to the Moon. In fact, the onboard computer apparently could have taken the whole journey by autopilot, and it's kind of the precision that you need with space travel that requires that computing power. And I suppose the point is, it seems that this decade, a lot of these technologies are all coming together now. Technologies such as 5G, the Internet of Things, AI, computing power, and in combination, they're creating remarkable new capabilities and opportunities. So I think really what we're saying here is that to broaden and make space travel in terms of its commercialization and more viable for paying customers, you're going to need that kind of symbiotic and similar progress in computing power and all these other digital technologies to make that possible. And certainly it could be that we will be relying much more on artificial intelligence in the future to automate those rocket launches and that piloting to the space stations of the future in orbit.
Okay, thank you. All right, and I'm just going to close this session out with Suzanne once more. I'm told that you're set to blast off this year in space. How do you feel about that? What can you tell us about that experience, that training to do so? What do you feel?
It's very exciting. So we actually don't know when we will have a mission because it's commercially funded, which means that we need to also generate the money for it. But it's, of course, super exciting. I mean, the training has been really life-changing, but the thought of going up into space is something different again.
Okay, thank you. Thank you so much, guys. And that's it for me for now.
Thank you, Janelle. Thanks for the question and this conversation. So let's check what kind of questions we receive from our audience. Okay, I guess we have one question here to both of you, Suzanna and Andrew. So I guess Suzanna could answer first. What are your perspectives on unmanned space vehicles? Do you trust that we are at that level or will be soon? For example, the use of in-space exploration. Suzanne?
So you mean space vehicles to travel to Mars or just into space? Because to travel into space, I mean, we are already there. We are traveling into space very reliably. So, I mean, there have been very few accidents in the last, 10, 15 years. So I think that part, we know the technology, things are working extremely well. If we want to go further afield, I mean, right now, there is the Artemis program, which is basically NASA and international partners trying to go back to the moon. And that is actually technologically a lot more difficult because you also need to then leave the surface of the moon again. But I think we're going to be there in the next 2 or 3 years. So I think we will have humans on the moon again in the next 2 or 3 years. I also think that in the next, say, 10 to 15 years, we'll have habitats on the moon. And possibly within the next, say, 20 years, maybe 30, we'll have the capability to go to Mars, at least from the technological side. So there are some issues with the health of the astronauts that really still need to be worked on. There is cosmic radiation, for example. There are the effects of prolonged stays in zero gravity, which are problematic on the health side. But I think technologically, yes, in the next decades, I think we'll go as far as Mars.
Wow, exciting news that we will get Mars in 20 or 30 years. Andrew, do you have any added comments, explanation to this question?
I do. I mean, I think, maybe it went a bit under the radar, but it does seem that, these are really exciting times, especially for this audience. And believe it or not, I'm not old enough to have seen the first lunar landing. I'm a bit younger than that. And I've been waiting decades for us to go back to the moon and do more manned exploration. I think the fact was that manned exploration of the near Earth system and the solar system was so expensive and so technically challenging that really only states, and even then the biggest countries, were the only ones that could really afford to have a manned space programs. But right now, because of all these amazing breakthroughs in digital technologies, engine technologies, we are suddenly seeing a kind of an explosion, a mini explosion in the number of private sector companies that are truly organizing and creating, as Suzanna was saying, SpaceX, you've got Blue Origin, you've got others that are really, you've got Virgin Galactic, that are making manned space flight available to everybody. So it's a really exciting time, and I think again with digital technologies, the way that we're improving AI, robotics, the speed that's happening, we are going to be able to do even more exploration. We're going to send up robots, hopefully, that are going to help us with the initial colonization of the moon and Mars, I think, by the end of this decade.
Thank you, Andrew, for the comments. And I would like to encourage all of our audience to ask more questions there. We will come back to you in the second Q&A audience part. Now, let's move to the second discussion led by Ernesto. Floor is yours, Ernesto.
Thank you so much, Maya. Well, the context is that I have a little sister. She's 11 years old, and she had a question for you, Suzanne. Her question is that when you are in the space station, how can you know which time of the day is? Because I mean, you are looking at the sun many times during like a day. So which is your standard time, or which time zone what do you use for reference?
So on the International Space Station, it's actually GMT, which is basically the winter time in the UK, so Greenwich Mean Time. That's the reference time on the International Space Station. But of course, if you just look out of the window, you can't tell what time it is because the ISS orbits our planet every 1.5 hours. So you have many sunsets and sunrises every day. But yes, you have clocks in order to tell the standard time. But for example, Tiangong, the Chinese space station, uses Chinese time as a reference. So in a way, you can choose any time on Earth in order to set your clock when you're in space.
Okay, I will tell her. And another question that she already has is that when you are rotating around the Earth and when you are like closer to the sun, does it feels warmer in the special station, or how does this work? Because to me it was a really interesting question because I never asked myself that. So yeah.
So I mean, you're not significantly closer to the sun. So the International Space Station is 400 kilometers above the surface of the Earth, which means that the atmosphere is extremely thin. There's hardly any atmosphere left, which means that basically if you're not in the direct sun, it's incredibly cold. So minus 200 degrees. It can be very, very cold. But if you're in the direct sun, it can be extremely hot, like plus 160 degrees. So obviously inside the International Space Station, the temperature is regulated. So it's very comfortable. It's about 20 degrees, but that is artificially regulated because the human body couldn't obviously survive these very strong extremes. But yeah, you're not significantly closer to the sun because the sun is hundreds of millions of kilometers away. So being closer to the sun doesn't really help. The main effect is that you're outside of the atmosphere of the Earth. So it's either very cold or if you're in the sun, very hot.
Okay, thank you so much. And the last question, and this is my question, that for you, which one you think that it's like the biggest challenge of space traveling? For you, with the many troubles that it could face, or all the variation that it could happen in space travel, for you, which one do you will consider that it's like the biggest challenge?
So I really think it's the human factor. I mean, if we're talking about crewed space flights, as in humans going to space, I really think the human factor is the main problem because we have sent space probes. The Voyager space probes have even left our solar system. So we've done a lot of exploration of the solar system with uncrewed space probes. But taking humans there is really an issue. And actually, one of the main problems is really how microgravity and especially radiation affects the human body. So astronauts that are on the ISS or on Tiangong, basically they're in the Van Allen radiation belt, it's called. So they're protected from cosmic radiation, similar to the way we are when we're on the Earth. But if we fly to Mars, we're going to get all this cosmic radiation. And if you're subjected to that for many years, it's extremely dangerous. So that's really one of the challenges. It's how to keep humans healthy for long periods in space.
Okay, thank you so much. And the other question is for I'm sorry, I'm sorry, I'm nervous. I forget your name, I'm sorry.
Andrew.
very special. Andrew, I'm sorry, Andrew. I'm sorry. It's just okay. The question is for Andrew, and how do you feel about the new improvements in technology that it will be? Because, for example, if we go to Mars, we will have like a lot of improvements in technology, and I think that some of those improvements or some of those innovations in technology part, it will be available for the public as well, or at least a version. How do you feel about it, or what do you think that it will work in the technology industry?
So I think, as I touched upon, it's a great question. What I think is really interesting is that this kind of delay, this stalling that we had with manned spaceflight in particular, but is the gap between the technologies that were needed then that really drove what Plato called the mother. The necessity is the mother of invention, compared to where we are today. And that's what I was kind of trying to draw out in my presentation, is that the wider technologies, the consumer-led technologies or business-led technologies have really caught up. And these are the ones that are supporting space travel. And it could be, so this is a glorious time, because suddenly it's not just governments that are doing space travel, it's private sector companies. And we've seen that with previous waves of industrialization, such as the automobile, or even the railroads. Once the private sector gets involved, they can they find a profit motive, and then you get the technology diffusing and becoming widespread. So this could be a really interesting decade for that. But where I think what could be really interesting is the advancements in digital technologies, in communications, kind of infrared laser technologies, means that a private sector company could put a robot on Mars. And it might be with VR technology. The capabilities for high resolution imagery could be that rather than with all the difficulty and expense of sending people up to the moon or to Mars, you could have an almost similar experience by just wearing VR goggles or something like that. And we could then walk around or feel like we're walking around on other planets. I think that would be a really interesting aspect of all this, is just how much robotics and AI kind of leads the way, takes us to the frontier, and supports future human endeavors. But I think that's where we're going to lead, and it will be led by the robots and AI, essentially.
Okay, thank you so much. And well, that's really interesting, and that makes me wonder, Suzanne, which type of technology as VR that is available for any market, like for the end user consumer market, do you use for training, like VR or something like that? Which item that you can have in any store that you use it for training or going to space?
So we used actually for training, it was VR goggles. I can't remember the make, unfortunately, but we used VR goggles to simulate the International Space Station. And I think that is a program that is commercially available. I don't know whether it's in every store, but I have seen it in museums, for example, that anybody can just go into this museum, put on the VR glasses, and can then feel and see what it's like to move around the International Space Station. And the best thing is you can even, without putting on a spacesuit, which takes several hours and is quite dangerous, you can even open the door and fly out and be flying among the stars. So it's a really, really cool experience, and I really recommend it.
Sounds really awesome. One other question, Suzanne. How does the medical part or medical assistant works during space travel? Because for instance, gravity is a really important part, because all the fluids like blood in our body will be different with the interaction with the environment in space. So how does the medical part or medical assistant how it works during the space travel?
Also, yes, if you have microgravity, many things happen to the body. Most of them are not desirable. So, I mean, one of the most obvious things that you see when you see videos of astronauts in the space station, for example, is they have very puffy faces. and they have very thin legs. And that's because the blood tends to, because there's no gravity, as you say, tends to travel up to the head, so that the face is more puffy. That in itself is not really a problem, but what is a problem is the lack of exercise. So without realizing it, if you're standing on the earth, you're always working against gravity. So even if you're sitting upright or you're just walking, you are doing physical work. And in microgravity, you don't have that. So one effect, if you don't counteract, is that your bone density will decrease and also your muscle mass will significantly decrease. So one thing that is currently being done already is that astronauts do a very regimented, very strong training program in order to counteract these effects. So there are certain effects that can be counteracted, but I've also seen some rather unsettling research on the human brain. So there's a lot of neuroscience going on what happens to the human brain in microgravity. So the conclusions are still not that conclusive, but I don't think in general humans are meant to be in microgravity. So that's why I said if we spend a long time in space, we really need to think about the effects on the human body.
Okay, thank you so much, Shan. And this question, I think that I will ask it for all the audience that is here with us today. And who can be an astronaut?
Ernesto,
So
I have to remind you that will be your last question. We're a little bit out of the second sessions, all right? But well, if Janelle, I noticed that you keep nodding. If you have the follow-up questions after this explanation, please go ahead. And we will move to the audience Q&A part.
Okay, I'll try and keep it brief, and I assume this is a question that many in the audience want to know. So maybe we're preempting the audience Q&A part. But so in the past, it was very simple. In the past, like in the 60s, 70s, 80s even, you had to be either a pilot or a scientist. And with the space stations, the scientific part became more important. So a large fraction of astronauts today are in fact scientists because they are supposed to be doing scientific experiments on the space stations. But I think in the future, this is going to break up more and more, especially with private commercial missions. I think we're going to not just see scientists, but maybe also, I don't know, poets and artists and people that just give us their unique view on space. So I really, really hope that we have this in the future, because I think the world really needs to see our planet from above, and we need people that can describe it to the wide public in many different ways, through paintings, through literature, through poetry, music maybe. So yeah, I really hope that in the future, anyone can become an astronaut.
Thank you.
Thanks.
Yeah, there's no follow-up from me. I'm just really intrigued and I've been fascinated with this.
That's great. Okay, that's the second part of the audience Q&A part. We received lots of questions from Latin America young people. So I guess this should be to Andrew. When talking about digitalization, we are also talking about data processing. Are we opening the doors for space travel to telecommunications engineers and others with similar knowledge?
Well, that's a great question. I would hope so, for sure. I mean, I know that there's already work that's being done to create 5G type networks for the future lunar bases, and the Tiangong station itself uses very advanced Wi-Fi comparable to kind of 5G download speed. So at some point, you know, as we reach out further, the requirement will be there. I'm sure certainly that expertise is already being used, and hopefully increasingly as we build things, we'll be needing to send up telecoms engineers into Earth orbit.
Thank you. From the same person, he or she asked the following questions to Suzanna. What advice can you give to a young engineer who wants to go into space? He said, I live in Latin America and here we don't have any space programs.
Yes, so unfortunately, right now, becoming an astronaut is very political because, well, space travel, as we've heard many times, is extremely expensive. And it's mostly the bigger, richer countries that are sending many astronauts. So I think if you live in the US, your chance statistically of becoming an astronaut is probably, I think, the highest in the world, based on population and on how many astronauts are sent up. But saying that, there are many smaller countries. My example in my talk was Saudi Arabia. They've just sent the first man and the first woman from Saudi Arabia into space via a commercial program. So actually, I think maybe the best thing is to write to your government or to find a company from your country, I don't know which country, something in South America, to sponsor you and to buy you a seat on one of these commercial spacecraft. So I think right now is really the time where this is becoming possible. So good luck.
Thank you. I hope our young people get these advices and could do something. And following the previous question asked by Anato, he asked the biggest challenge. Actually, our audience is also want to know, because people would like to travel to the space one day. We hope that everyone could travel there. So according to you, Suzanna, why is space travel so expensive? And do you foresee a way for this to be offset? For example, competition, industry growth, etc.
Well, space travel is very expensive, and I'm not sure we'll be able to get every person on this planet into space because we have many, many people on this planet. But saying that, when we started flying with planes, it was only very, very few people that could afford to go on a plane to travel somewhere. And these days, many people have traveled on planes, and many travel very regularly on planes. So I think it is becoming already much more affordable. Where we're seeing it first, I think, is in the uncrewed space flights. So sending small probes, robotic probes, payloads into space is already becoming much, much cheaper through companies such as SpaceX, but not only SpaceX. There are many commercial companies that are making space flights much, much cheaper. The problem with the human factor is always that you have very strong security requirements. Because traveling into space, it is still an extreme adventure. It is still very, very dangerous. So you have to adhere to all these security protocols, and that still makes human spaceflight very, very expensive. But I do think the price is going to go down in probably the next decades.
Good to hear that. Another question from our audience. How do you explain to your loved ones that the risk of traveling to space is worth it? And he asked also another question. How would you say to 11-year-old girls to motivate them for science and technology? Oh, I didn't know that we have that young viewers, maybe the relatives of these viewers. So Suzanna?
That is great. That is really great because, I mean, well, for me personally, and this is also the mission of the Astronautin, of the company that is trying to send me to space, but also of myself. One of our main objectives is really to empower girls and young women, especially in the STEM sectors, so that also girls think that maybe they could become engineers or work in IT or technology, because very often I talk to young girls and they're like, oh, I'm not very good at computers. I find that very difficult. I don't really understand it. I can never work in that industry. And I say, no. That is, you're 10 years old or 11 years old. Just because you can't do something right now doesn't mean you're never going to be able to do it. So me as an example, I was really no good at physics until I was about 16. I had very bad marks at school in physics, and I always thought I can't do it. But then I got a good teacher, and I was suddenly very interested, and I studied hard, and then all of a sudden I was good at physics, and now I'm becoming an astronaut. So yeah, I really hope that my story can then also inspire our 11-year-old viewer. And sorry, the first part of the question I've now completely forgotten. So if you could repeat that, that'd be great.
Think that's a similar one. It asks that how do you encourage and explain to your loved ones, I guess the relatives or friends, that the risk of traveling to space is worth it?
Yeah, so that is a tough one. And actually, when I applied to become an astronaut, my parents were very, very worried. But well, I said, I'm grown up. It's my life. So it's more to explain to myself that the risk is worth it. I think that's really the fundamental thing. And yes, there is a big risk associated with space travel, but I think technology has come to a point where the risk, at least for me, is acceptable for what I would gain and what also the world is gaining from having crewed space flights. So it's a risk to take, and I think every person needs to decide for themselves. Many people say the risk is too big for me personally, and that's absolutely fine. But I personally think that if we want to move forward as a society, we want to also go into space, we want to go further, then we have to take this risk, but of course with the necessary security measures.
Thank you so much. Andrew, as an advisor and expert, do you have any encouraging words to our young people to know in STEM?
Well, yes, as I said, I think this is this could be a really interesting time to be alive. Certainly the next decade or so, we are going back to the moon. The Artemis program is going to do that. I think the next flight is in next year, that soon, where they'll go round and then they're going to try and land some people on the moon in 2025. And I think, as I said, this confluence, all these digital technologies coming together, this commercialization of space means that we're entering an unprecedented era. So I think work hard on those STEM subjects and think about if you want to get involved in space travel and the space race, think about digital technologies as well, how they can play a part in all this. But yeah, I mean it's a good time, I think, for to be around and be young for interest in space travel right now.
Thanks. Because of the timing, so here will be the last question from the audience. Now, as we expand our presence in space, so we'd like to discuss some future potential ethical considerations, such as in terms of exploration, colonizing other planets may lead to the conflicts. So what do you think, Suzanna?
Well, I mean, there are already conflicts about space. So, I mean, the Earth orbit is full of satellites, of space debris, and there are as yet no binding regulations for what happens. For example, if you send up a satellite and it breaks, it just stays there as space junk, and it can be a hindrance or even dangerous for astronauts, for example, going into space. So I think space law and really governing what happens in space is something that needs to be strongly developed and very quickly, because we are moving forward. In terms of colonizing, that's going to be interesting. I mean, I guess the good thing is if we go to Mars, we astronomers are pretty certain there is no life there. Well, yeah, we're not 100% sure, but I'd say 99% sure that there's no life. So at least we wouldn't have the problem of, destroying another civilization or another, I don't know, set of bacteria or something. But of course, who gets there first? Who would get what part? Who would be allowed to live there? That would be extremely difficult to regulate. And I really hope that we get our act together as a planet and manage to, go there as planet Earth rather than as individual countries.
Oh, to say I'm filled with a sense of inspiration would be an understatement. There were such insightful questions and interesting answers around space travel, the challenges, opportunities it presents, the indispensable role of digital technology getting us there and play it there. We've rocked around the space, and it feels like there are limitless possibilities that lie before us. So we're about to the end of our webinar. I'd like to invite every guest to speak your last words to our audience. Dr. Suzanna Randall, you're first. Anything you want to share?
Yeah, I think it's very, very short. ad astra, which means to the stars, and hope to see you there.
Thank you. And our seeds ambassadors, Janelle, your turn.
Sure, I'd like to encourage our audience to just keep on pushing because clearly the sky is not the limit.
I guess so. And Ernesto, something you want to say to our audience?
Well, I want to encourage all the audience to take any opportunity that it presents to you, because you don't know that where it will take that step that you will take. You never know. You can maybe end up with Suzanne in space.
We never know. And the last one, my dear colleague, Andrew.
Yes, well, I think in the near term, you're going to have to work very hard and save hard to afford a ticket to go into space. But yeah, I mean, it's not easy to set up an internet giant to build your own rocket. But I really believe, given the research that we've done over time, by the end of this decade, going into the next one, we may see a kind of, a lot more, thousands of people maybe going up into space orbit, Earth orbit rather, maybe visiting the moon. So, start saving now.
Thank you, and thank you our all amazing guests and seeds ambassadors. Your expertise, insights, and enthusiasm truly made this a memorable experience. And now look at the camera. Let's keep smiling and take a group photo together. Let's remember this moment. And thanks to everyone who joined us today online. It's a goodbye now, and we hope to see you in the next Seeds for the Future event soon. Stay tuned. Bye.